Hello, welcome to this video. In today's video, we would like to write a program to input data for two students, display their information, and find the average of total marks. And we would like to have a structure for storing our information that we are using, that they're reading from the user. Here is my structure. I have the struct keyword. The name of my structure is student. There are three variables inside this structure. I'm having a string, one integer, and one float. The string name is name, the integer name is age, and the float name is total marks. In the int main function, first of all, I create two objects from the student structure to manipulate data in this structure. Then I'm going to show the user enter details for student 1. Then we show the name. Okay, just enter the name. And whatever the user is going to enter, we're going to use the first object dot name, meaning that we're accessing the name variable using the first object, and we are storing the data here for the first student. Okay, so whatever the user is going to enter here, we're going to use the getLine function to store it in the name variable using the first object that is called s1. So s1.name, this is the name of my string. So here I'm going to store the name that the user is going to enter. Then we are showing this message, age, meaning that enter the age. Then we are again using the object s1 dot age. This is the name of the variable in my student structure. So I'm using the s1 object to access that variable. So I'm storing the age of the user that is entering using the first object that is created from the student structure. After storing it, we are showing this message total marks. Then we are using again the first object and then dot total marks, which is the name of this third variable, and we are storing whatever the user is going to enter into this third variable. Then we would like to ask for the second student data. In order to store the second student data, I'm going to now use the second object. So the first object was for the first student, and the second object is now going to be used for the second student. Again, I'm showing this message, backslash n helps us to go to next line. So backslash n before starting this message, and at the end of this message, we are making sure that we are in a new line when we are showing this message to the user. So we say enter details for student 2, then we ask for the name. Whatever the user is going to enter, we are using the second object s2 to store it in the name variable. Then for the age, we are using again the second object for the age variable, then the age variable, and then we're using the second object for total marks. So whatever the user is going to enter, we are going to store it in the name, age, and total marks variables using the second object s2 because it's for the second student. Okay, so this is the information that we were planning to get from the user for the two students. Then we would like to display the information of these students. In order to display them, we can have this message student one details, and then in the next line name, and then call this name variable using the first object. Then the age, calling the age variable that we stored using the first object again, and total marks using the first object. Then we show this message saying that student 2 details. Then we type down the message name and we call the name variable, this time using the second object. So the information that we stored for the second student is going to be displayed, and then the age and total marks both using the second object. So this is how we are going to show the information that was stored for these two students. Then we discussed that we would like to calculate the average marks. Here we mentioned find the average of total marks. So student 1 is going to have 1 mark and student 2 is going to have another mark, and we would like to calculate the average of these two marks. In order to do that, we are having a new variable called average marks. Then we are going to call the variable total marks using the first object plus then total marks using the second object. So we are calling the total marks of the first student because I'm using the first object, and then the second student I'm using the second object, divided by 2 because there are only 2 students. Then when we are the result of this division is stored in the average marks variable, then we show this variable in the output. So let me run the code once so we can see how it works. It says enter details for student 1. So this is the message, enter details for student 1. This \n is because after 1 and colon it goes to next line. You see, this \n helps to go to next line. Then it says name. So when it says name, I would type down, for example, Reza. Then it asks me for age. So Reza is already stored in the name variable using the S1 object. Okay. Now it says age. I would say 33. It says total marks. I would say, for example, 100. After storing the information for student 1, here it is showing the message saying that, okay, you see \n before and \n at the end of the sentence. So we are having next line and this message is being printed, and then we are having a \n at the end. So it is going to the next line as well. So it says the second student, for example, the name, I would say John. It says age, I would say 35, and total marks, I would say 90. Then it is going to display the information of the first student and the second student. So student 1 details, name Reza, age 33, and total marks 100. And student 2 details, name John, age 35, and total marks 90. And average total marks 95. How we got this 95? Because the total marks of Reza and total marks of John are being added to each other and then divided by 2. So 190 are added, 190, and then they are divided by 2, and the output will be 95. So this is how we can create a structure, store data in a structure, and then display the information in the structure and calculate, for example, the average mark for 2 students. Thank you for watching. Hello everyone, welcome to this video. In this video, we would like to write a program that allows the user to store either Celsius or Fahrenheit temperature values in a unified data structure using a union. The program should provide an option to convert the stored temperature from Celsius to Fahrenheit or vice versa. We are going to use the union to conserve memory by holding only one type temperature at a time. So we know that this is one of the features of the union. And here is my program. So I'm having a union called temperature. And this temperature union has 2 variables, one Celsius and one Fahrenheit. Okay. Then I'm having a function called convert to Fahrenheit. It's a void type, so it's not going to return anything. Basically, it gets the object of this temperature union, and it's a call by reference, so we are going to directly modify it. And then it is going to convert the entered Celsius to Fahrenheit. Okay, so whatever the user is going to enter here, and when calling this function, that is going to be converted to a Fahrenheit temperature. Then I'm having a function here called convert to Fahrenheit. It accepts one argument that is object of this temperature union again. With this difference, in this function, we are going to enter a degree in Fahrenheit, and it is going to calculate the Celsius for us. Okay, so it is going to convert the entered Fahrenheit temperature to Celsius. Then here is my int main function. In my int main function, before doing anything, I'm creating an object of this temperature union. Okay, so I type down the name of the union, and then I type down the name of my object. It is called temp here. It could be X, it could be Z, whatever we want. Then I'm going to have a character called choice, and I'm going to ask the user enter C for Celsius or F for Fahrenheit. So I would like to know the user is going to enter a temperature in Celsius or in Fahrenheit. It is very important for me because if it's a Celsius, I need to call a function to convert the Celsius to Fahrenheit. And if the user is going to enter Fahrenheit, I need to know it to call another function to convert Fahrenheit to Celsius. So it's important for me to know which one the user is going to choose. So enter C for Celsius or F for Fahrenheit. Then whatever the user is going to enter, I'm going to store it in the choice variable that is of character data type. Then I'm having my if-else condition here. So I would say if that choice that we are in which we are storing the input data of the user, either C or F, if that choice equals capital C or lowercase c, because it's an insensitive program that we are writing, either this or this, we are using OR operator. If this is the case, ask the user to enter temperature in Celsius. And whatever that the user is going to enter, we are going to store it in the Celsius variable. This is the Celsius variable. It is one of the elements of the temperature union. In order to access this Celsius variable, I type down the name of the object dot the name of the variable. Okay, so we're storing it here, and then I call the function convert to Fahrenheit, and I'm passing this object to this function. So convert to Fahrenheit function is this one, and here I'm typing down the Fahrenheit variable. This is the variable, and in order to access it, I type down temp.Fahrenheit equals, this is the formula to calculate the Fahrenheit equivalent of the input Celsius that we discussed. Because here I'm storing the data already in the Celsius variable, and then I'm just passing this object of my temperature union in order to be able to be used in this function to call Fahrenheit variable of this union and Celsius variable of this union as well. So this is the formula of how to convert a Celsius degree into a Fahrenheit degree. Okay, and I type down temp.Fahrenheit to store the output in the Fahrenheit here. Then when the calculation is done, I'm going to show this message temperature in Fahrenheit, temp.Fahrenheit to access that variable, because we calculated the conversion and we assign it to this variable. Now I'm calling that variable to be shown in the output. However, if the user have chosen F instead of C, I have an else condition here saying that if the user chose F, capital F or lowercase f, enter the temperature in Fahrenheit. This message is going to be shown in the terminal for the user. Then whatever the user is going to enter, I'm going to store it in this variable Fahrenheit using the object temp. Then I'm calling another function that is called convert to Celsius, and I'm passing as argument this object of the union. Then here is the convert to Celsius function. Here I'm having this temp.Fahrenheit, we got it from the user, and this is the formula to convert a Fahrenheit degree or temperature to a Celsius degree or temperature. And whatever the output of this equation is, it is going to be assigned to the temp.Celsius, so this variable is filled. After the calculation is done, we are showing this message temperature in Celsius and then calling the variable Celsius using the object of that union. And this is how actually we are going to convert the temperatures either from Celsius to Fahrenheit or from Fahrenheit to Celsius. And if the user is going to enter anything but C and F, we are going to show this message invalid choice, because we ask the user to enter either C or F. If, for example, the user is going to enter R, it will be an invalid choice. So let me run the code. So when I run the code, it says enter C for Celsius and F for Fahrenheit. So if I type down R, it says invalid choice. You see, invalid choice, because R is not included in any of the if conditions here. So I run the code one more time. I say C. It says enter the temperature in Celsius. For example, in Celsius, the degree is 20 degrees. So the equivalent of 20 in Fahrenheit is 68. This is how it is calculated this for me. And now I'm going to use, for example, capital C. When I type it down, it's okay. So it's insensitive to lowercase or uppercase, okay? Enter the temperature in Celsius. This time I'm going to say 28. It says temperature in Fahrenheit is 82.4. So when I run the code one more time, it asks me to enter C or F. So I choose F here. It says enter temperature in Fahrenheit. Now I'm going to say, for example, 70. And it says temperature in Celsius approximately 21, for example, here. So this is how basically we can have a program using a union to convert Celsius to Fahrenheit or Fahrenheit to Celsius. Thank you for watching. Hi, welcome. In today's video, we would like to write a program to manage an event registration system where each event has either a number-based code or a name. Use a union to store event information and demonstrate adding, retrieving, and displaying events. So when I run this code, it asks me enter C to input event code or N to input event name. So I type down C and it says enter event code. I type down 123. It says stored event information, event code 123. And when I run the code one more time, it asks me, for example, to enter C for code and N for name. I type down N, for example. Now it's word cup. Okay. So when I enter, it says stored event information, event name, word cup. So this program is written like this. So here I'm having a union called event info. There are two variables in this union. The first one is event code, and it's of integer type. The second one is a fixed character called event name with 50 size. So we are having a fixed character event name. Then I'm having a structure called event, and this structure event is having two variables here. So the first variable is a Boolean variable and it's is code, okay? And the second one is the object of the event info union. So the event info union has one object that is called info and it is inside the structure event, okay? So here up until here. Then I'm going to discuss this function later. Then here is my main code, okay? So my main function, first of all, I'm creating an object called event from the event structure, okay? So I'm creating an object called event from the event structure. And inside the event structure, I'm having the object called info from the event info union, okay? Then I'm having a character called choice. I'm showing this message to the user saying that enter C to input event code or N to input event name. Whatever the user is going to enter, we are going to store it in the choice variable. Then I'm having one if-else condition here. So in the if-else condition, first of all, I check to see if the choice equals capital C or lowercase c, because this is a program that is insensitive to uppercase or lowercase. So this is why I'm including both capital C and lowercase c. Therefore, if the choice variable equals to C or C, we're going to assign true to isCode variable from the event structure. So here is, let me go a bit down. Okay. So here is the isCode variable. It's of Boolean data type. Okay. So if the user is going to enter C, I'm going to assign true to this variable. So this variable equals true when the entered information by the user is C. So they want to enter a code. we are going to assign true to is code variable. And how to access this? I'm going to use the object of the event structure. And the object of event structure is the event. Okay, this is the name of the object. So event dot is code, the name of the variable, helps me to access this variable. So I'm assigning true to this one. Okay. And then I'm saying that, okay, enter the event code. And when the user is going to enter the event code, I'm having my union called event info. I'm going to store it here. Okay, store it here in the event code variable in the event info union. In order to access that, whatever the user is going to enter, I'm going to store it there. But how can I access this one? I don't have in the int main function, I don't have any object of this union. You see? But I have an object of the event structure, and inside the event structure, I have the object info from the event info union. Therefore, to access this variable, I'm going to use the event object and then the info object. So I type down event.info and down .event code. To access this event code variable, I type down the name of the object of the event structure. Okay, so this is called event. Then I type down the name of the name of the object from that union that is inside the event structure. So info, the variable, the object that is here defined, that is the object of the event info union, and then dot the name of that integer variable. So whatever the user is going to enter, I'm going to store it in the event code variable using the object of the event, then the object info. Therefore, we can access it. Okay. So this is what happens when the user is going to enter C. So when the user is going to enter C, we are going to assign true to the is code and then ask for the code and then store it in the event code. Okay. So imagine that the user entered C. So this part is executed, and then we are not going to go through the other parts of the if else condition, and then we are going to show this message stored event information. Then we are going to call display event function, and we are passing as argument the object of the event structure. Okay, so this is the argument, and we are calling display event function. So this is the display event function. It's a void type, so it's not going to return anything for us, and it has one argument, and the argument is the object of the event structure, and it's a call by reference. But because I don't want to do any modification, I type down the keyword const. Then here I check to see if event.isCode. So this variable, if this variable is true, it means that the user entered a code for the event and not a name. So the user entered the code when we assigned this to be true, yes, because the user chose C. So we assign true to this variable, and then we ask for the code, and then we store the code. So if this is code variable is true, it means that the user entered a code, and we are going to, this condition is true, so we are going to execute this part, meaning that we are going to show event code, and we are going to show the code that is entered by the user using the object of the event structure, then object of the union that is inside the structure event. Okay, so this is what's going to happen, what is going to happen when the user enters C. When the user enters N, so imagine that we are running the program one more time, and the user enters C. So C is stored, N is stored, in the choice variable. Then here in the else if part, we are checking to see if choice equals N, either capital or lowercase. Okay, because it's not, this part is not true because N is not equal to C, so this part is not going to be executed. And this part, N equals N, either capital or lowercase, so this one is true. when this condition is true, this part of the code is going to be executed. Okay, first of all, we're going to assign false to the is code variable. So whenever that the user is going to enter code, we are going to assign true to this variable. Whenever the user is going to enter a name, we are going to assign false to this variable. Then we are asking the user enter event name. Okay, we are asking the user to enter event name. Then we are going to store the entered event name in the event name character that we are having here, event name. Okay, this is the event name. And to access this variable, because it's in the union event info, I'm using the event. Let me type it here. Event object dot info, the object of the union that is inside this structure, dot event name. Okay, so this is how I'm going to access that variable, and this is the size of the character that we are having it here. Then whatever the user is going to enter is going to store here. Okay, then we are not going to jump into any other parts of this if condition because only this part is true. Then we are showing this message, stored event information, and we call the display event and we pass as argument the object of the event structure. So this function is called this time, and here it checks to see if the is code variable is true or not. Here when the user entered n, we assigned false. Therefore, this condition is not true. Okay, so this part is not going to be executed. Instead, this else part is going to be executed. And here we are asking to say an event name. And when this message is printed in the output, we are going to call this character here. And in order to access that, we type down the object of the event structure, then the object of the union that is inside this structure, and then the name of this variable here. And whatever the user entered is going to be shown here. So when I run the code one more time, I type down C, it says enter the event code. I would say, for example, 14, and it says store event information, stored event information, event code 14. Okay. So, and when I run the code one more time and I enter n, it says enter the name of the event. So I would say WordCup, for example, and it says stored event information, event name, WordCup. And we have one else here. So if the user is going to enter anything but C or N, it is going to fall into this else part because choice is neither equal to C nor equal to N. So it is going to fall into this else part, and we are going to show invalid choice message to the user. So for example, here it says enter C to input event code or N to input event name. So I type down J, it says invalid choice because this is not considered in any of the conditions that we provided here in the code. So this is how we can manage an event registration system using a union and a structure in C++. Thank you for watching. Hello everyone, welcome to this video. In today's video, we would like to have a display traffic message function that shows the status and the current status of the traffic light. Here is my enumeration, or let's say enum. Here is the name of the enum called traffic light, and there are three elements, red, yellow, and green. Okay. Then in the main function, I'm creating an object of this enum that is called current light, and this is the name actually of the enumeration or enum here. So in order to create an object of this enum, I type down the name of the enum, then I simply type down the name that I would like to have for the object. Then it is assigned, for example, to red. It could be assigned to any of these elements. It could be assigned to yellow, green, or red, whatever. So it's our choice. We're going to change it as well. Then we are going to ask this function to be activated. So I'm calling this function called display traffic light message. And then in parentheses, we are having the current light. So current light, this is the object that is being passed to this function. This is the object of the enumeration or enum traffic light. And we are passing it when we are calling this function. So this is the function. The name of the function is display traffic light message. It's of void type, so it's not going to return anything. And it accepts one argument that is an object of the traffic light enum. Here we are going to have a switch statement for considering different conditions. We could use, for example, if conditions if we wanted. So this light that we are having in parentheses for the switch statement is exactly the object that we passed to this function, but here we name it light. We could name it anything. Here is the light, and in case light is red, so this red now has been passed to the function because red was assigned to the object and object was passed as argument to this function. So if light is red, for example, in case that it's red, show this message. Stop, the light is red. And if in case it is yellow, show this message. The light is yellow, for example. Or in case it's green, go. The light is green. And otherwise, if you're going to assign any other thing apart from these three, it is going to say invalid state. So when I run this code, it says stop, the light is red because red was assigned. So if I type down, for example, green here and I run the code, it says go, the light is green. And for example, if I have, the case yellow, for example, and when I run the code, it says the light is yellow. So be careful. So this is how we can use enum to have these new elements defined and actually assign them to an object of that enum and have a switch statement. So each of them, whenever each of them is happening, there should be another condition that is taken care of. For example, in case that it's red, it is going to have this message, while when it is yellow, it has another message, while when it is green, it is having another message. So this is how we can have a traffic lighting system implemented in C++ using enumeration and switch statement here in CPP. Thank you for watching. Hello, welcome back. In today's video, we would like to write a program to manage student records using a structure. Each student should have a name, a roll number, and marks in 3 subjects. And the program should calculate and display the total and average marks for each student. Here is my structure. I'm using the struct keyword to build and create my structure. The name of my structure is student. There are 3 variables, name, roll number, and marks in my structure. Then I'm having a function here that I'm going to discuss later, and it's my main function here. So I'm creating, first of all, an object of the student structure, okay? The object is called student. Then I'm showing this message, enter student name, and then I use the getLine to store the name of the student in the name variable here in my structure. But in order to store it, I type down the name of the object first and then the name of the variable, which is name in this case. Then I ask the user to enter the roll number, and then again I'm going to use the student object dot the roll number, the name of the variable, which is the name of the variable in my student structure. So the object name dot the variable name that is inside that structure. And using the cin, I'm going to store it as well. Then I'm going to ask the user enter marks for 3 subjects. Because we're going to ask the user to enter marks for 3 subjects, it's easier to use a for loop. We're going to have a for loop with I iterating variable starting from 0 as long as I is lower than 3. Then whatever the user is going to enter, we are going to store it in the marks variable here. And I'm using the object student.marks here to store it in this variable, these 3 subjects. Then after having all this information, I'm calling this display student details function, and I'm passing the student object, which is an object of the student structure. When I call this function, then I'm passing this object as an argument. So display student detail. Let's go and see what this function does. Here is the name of the function, that is display student details. We see that it's a void function, so it's not going to return anything. And here we see that the argument is an object of the student structure, and it's a call by reference. We see it because we're having the AND operator, and we're going to therefore directly work with this object, but we're not going to do any modification with it. This is why we're having the const keyword here. I'm having a variable called total, and it is initialized to be 0. And then I'm having a for loop starting from 0 as long as I is lower than 3. And I'm going to calculate the total of the marks of the student. For example, here, total equals total plus student dot marks I. Okay, and I is going to take values 0, 1, and 2. For example, when it is 0, let me copy paste it in the next line as well. So one time it's 1, one time it's 2, one time it's 0. So when it's 0, it is going to calculate the total based on the first mark. For example, imagine that the student marks are 100, 90, and 80. So the first mark that is stored in the marks variable here is 100. So 100 plus total, and total is initialized to be 0. Therefore, we are having 0 plus 100, 100. Therefore, total equals 100. Okay. Then we are having 100 plus 90. Why 100? Because we are having total plus the second mark, and 100 we calculated in the previous iteration, that is 100, plus the second mark, which is 90. We assume that it's 90. So the output is 100 total equals 190. Then we are having 190 because it's the total from previous iteration plus the third mark. Okay, when we are having this plus the third mark, we are going to have total equals to 270. So this is how we can calculate the total of the marks of the student using a for loop, and this is the formula. And this formula equals this formula if we are having an I here, for example. Okay, if this is I, this formula is identical to this formula. But if it's easier for you to type it down like this, type it like this. Otherwise, you can type it as well like this. The functionality is the same. Then when the total is calculated, we are going to divide it by 3 because we want to have the average, and there are 3 subjects. So we're going to have it divided by 3 and assign it to a variable called average. And finally, we are going to show the details of the student. So we are going to say student details, and then name, roll number, total mark, and average mark. So in order to call any of these variables that are in the structure, we're going to use the object. So object.name of the variable, which is name. So this is the name of the student. In order to have the roll number of the student, I'm typing down the object dot roll number, which is the name of this variable. And then total marks, we are having it in here because here is the total mark and we calculated it here. And then average marks, we calculated here, and then we are having the average. So these two, because we calculated in the current function and they are not stored in the structure, we don't need the student object to call them because they are just here, declared and initialized. They are not a member of this structure. So let me run the code now. When I run the code, it says enter student name. I type down Reza, enter the roll number, I would say 1, for example, and enter marks for 3 subjects. I would say 100, 90, and 80. So it says now the student detail exactly as we expected here in the function. You see? Name Reza, roll number 1, total marks 270, average marks 90. So this is how we can have a student record in a structure in C++ to store the details of different students. Thank you for watching. Hi, welcome to this course. In this video, we would like to write a program to manage a store's inventory using a structure. Each item should have a name, item code, price, and quantity. The program should display the inventory and calculate the total value of all items in stock. So here is my structure. We're using the struct keyword, and the name of the structure is item. There are 4 variables here: name, item code, price, and quantity, as the statement asks: name, code, price, and quantity. So we are having 4 items, 4 variables in the item structure. Here is my function to display the inventory. We're going to discuss this later. And here is my main function. So in the main function, first of all, I create a vector of a vector that stores objects of the item structure. So this is the item structure. Okay. And we know from before, when we wanted to declare a vector, we had to say it's a vector of integers, for example, called x. Okay. Now we are creating a vector that stores object of items structure, and it is called inventory. Okay, so inventory is a vector that stores objects of the item structure. Then we are having a variable called n. We are asking the user to enter the number of items. For example, the user is going to choose, okay, I'm going to give information about the inventory of 2 products, 5 products, 10 products. So whatever the user is going to enter, we are going to store it in n. Then we are going to have a for loop to store all the data. For example, if the user is going to enter 2 items, we are going to have I equals to 0 and I equals to 1, I equals to 0, I equals to 1, and n equals 2. Okay, so we will have 2 iterations when the user wants to have 2 items. And in the for loop, I'm creating an object of the item structure. So the object that I create from the item structure is also named item. It could be anything. In order to store and access the data and variable in the structure, we need to create the object. So here I would type down this message to the user saying that enter details for the if plus 1 item. For example, when I equals 0 in the first iteration, 0 plus 1, it shows the message enter details for the item 1 and then for the item 2. We are basically having I plus 1 because in C++ we start from 0 and we started our loop from 0, so we don't want to say, okay, enter details for item 0. We are going to show this message item 1. Then we say, okay, enter the name, whatever the user is going to enter. I'm going to use this item object that I created here from the structure, dot name. So name is the variable that we have in the structure. The first variable in the item structure is name, and it's of a string data type. Okay. So we would like to type down item.name. So whatever the user is entering is going to be stored in the name variable using the item object, and we use getLine to store it. Then we show the message, okay, item code, now give us the item code. We are typing down the object again, dot item code, which is the variable that we have here in the structure. So whatever the user is going to enter, it is going to be stored in item code, okay? Then we say, okay, what is the price? Tell us the price, item dot price, and we are going to store it in this price variable. And then we are having the quantity, and here we are going to use the object item dot quantity here, and it is going to be stored here. So, and now it is for the, when it is for the first iteration, it's for the first product. So when we are having a 2 iteration in this for loop, in the first iteration, we are going to store the data for the first product, because at the end, whatever that is here that is stored, we are passing this object to the inventory vector. So the inventory vector that we have is a vector that stores object of item structure. We just declared it just before the for loop. And after doing all of these things, we are passing this object to the inventory vector. We are using the pushback function to insert this information into the inventory vector. And when the first loop is finished, we are going to go up again, I equals 1, and we are going to ask again. We are creating the item object. We are asking about the name, the code of the product, the price, and the quantity. Then whatever again is entered, it is going to be stored in the variables in the structure above, and then it is going to be pushed back to the inventory at the end vector. And finally, when this for loop is finished, we are going to call the display inventory function, and we are going to actually pass this vector inventory as argument to this function. So let's go up and see what this function does. Display inventory. So this is the display inventory function, and it is getting one argument with call by reference, and we are using the const keyword to make sure that we are not making any modification to the original vector. So it's a vector of that stores items uh, of the item that stores the objects of the item structure. So here in the beginning, I'm having a float that is called total value, and it is initialized to 0. I'm showing this message first of all to the user. So \n, we know from before, it is going to get us to a new line, and \n. So we are going to have a new line before this message and after this message. Inventory details. Then we show this message: item code, name, price, quantity, and value. Okay. Then we are going to have a for loop. A for loop we are having here that we are iterating through this vector called inventory for each item. And in each iteration, we are going to calculate this value float. For example, we are going to mention in the first iteration, multiply price by quantity and assign it to the value variable. And then add this value to the total value that we have declared as to be initialized in the beginning. Okay. And then see out the item code, item name, price, quantity, and then the value. Okay. And here, in order to call these variables, we use the item object that we are creating here. So this item, this is the iterating variable that is going to for each item in the inventory vector. So this item is our iterating variable. So we're going to have this item dot item code, item dot name, item dot price, etc. And it is going to give us the information in the output. So when I run this code, it says enter the number of items. So let us go here together. So enter the number of items. I would say, for example, I have 2 items. Then, okay, here it says enter details for item 1. Okay, and the first one is name. So the name, for example, is cheese. Item code is 1. You see here, this is name, item code, and then now it is asking for price. The price is 3, for example, dollars, and quantity we have 50 in the inventory. Then it goes back up. Now we are having enter details for item 2, enter details for item 2, and the name, I would say, for example, milk. Item code, it's 2. I would say price is $5, and quantity we have 100. And now this is the message that is being printed in the output for us using this function. So first of all, we are having the inventory details. So inventory details, and we are having a table here, as you see, item code, item name, price, quantity, and value. So item code, name, price, quantity, and value. And this gap is created by \t. Okay. Then after that, we are having the item code being printed here. So this is the item code, for example, 1. Then we are having \t to have this gap. And then we type down the item name, item price in the first iteration, item quantity, and value. So item name, item price, and quantity and value. Basically, this value is the price multiplied by the quantity that we calculated here, okay? So the price multiplied by quantity is assigned to this variable called value, and then value is added to the total value in the end. And we are not yet showing this total value. We are for the moment we are showing only the value. So the value of the first row is, for example, $150. Okay. Then we go up back again because we are having two items in our vector, in our inventory vector. The first item was for the first product, cheese, and the second item is for the second product, milk. Okay, so now that we printed out everything for the cheese, we're going to now show the information for the milk. So we are saying that, okay, item code is 2 now, and then item name milk, item price we set 5, item quantity is 100, and the value we calculate here, price multiplied by quantity, price multiplied by quantity, so it's 500. And then 500 is added again to the total value. In the previous iteration, total value was 150, okay? Because we calculated the value in the previous iteration, we assign it to the total value. So total value was initialized to be 0, but then after first iteration, it became 150. And now in the second iteration, we calculated the value to be 500, quantity multiplied by price, so 500. And now 500 is added to already existing 150. Therefore, it becomes 650. Okay, when it becomes 650, after the end of this for loop, we show this message, total inventory value, and then we show this variable which is shown here, total inventory value $650, for example. So this is how actually we can use a structure and vector of objects of that structure to store data for an inventory. Thank you for watching. Hello everyone, welcome to this video. In this video, we would like to write a program to manage an employee payroll system using polymorphism. So the system should have two types of employees, salaried and hourly. Each type should calculate their salary differently. Fixed monthly salary for a salaried employee and hour worked multiplied by hourly rate for hourly employees. And we are going to use polymorphism to activate this. So here is my base class. The base class name is employee. In the protected part, we are having one string called name. And in the public part, we are having a constructor here. And this constructor is going to assign whatever that is, whenever we are going to create an object of this class, the constructor also is activated, and we need to create an object. When we are creating an object, we need to initialize a string as well, and this string that is, for example, emp name is going to be assigned to the name variable in the protected part. So whenever we are going to create an object of this employee class, we need to have one string in the parentheses as well to be able to create the object, and then that argument that is inside the parentheses is assigned to this name string. Okay, and here we are having a destructor as well, and then we are having a virtual void function called calculate salary, and it's a pure virtual function because it is initialized to be 0. Then we are also seeing a virtual function called display info, and it is going to basically show whatever that is stored in this name variable. Okay. Then we are having our first derived class that is called salaried employee. So it is derived from the employee class. It has one variable called monthly salary, and the constructor that is with the same name as the class. And whenever we are creating an object of this class, we need to have two arguments, one string and one float for the salary. Whatever that we are going to pass to this pass as argument for the second argument, for example, the salary, it is going to be assigned to this monthly salary variable. And the first part that is a string, that the first argument that is a string, whenever we are going to create an object, the first argument is a string, and that string is going to activate and call this employee constructor, which is the employee of the first class or the base class, let's say. And this constructor is activated, and this argument is going to be assigned to the name variable. So let me say it one more time. Here, when we are creating an object of the salaried employee, we need to pass two arguments, and it is separated by a comma. The first argument is a string, okay? And we don't want to change it. This is why we are having the const keyword. And that name, that string that is assigned as the first argument, that is passed, let's say, as the first argument, is going to call the employee constructor, which is the constructor of my base class. And when this constructor, we said that when this constructor is called, we need to pass one argument, and that argument should be of a string type. And we are passing this string argument when calling this employee constructor. And that string is going to be assigned to the name variable that is a protected variable of the employee class. And the second argument, which is the salary, is assigned to monthly salary variable, which is a variable of the salaried employee class. Then we are override this calculate salary, because here we had a pure virtual function. And for the salaried employee class, we are having the calculate salary function. And because we would like to override it, we type down the keyword here, and then we show this message monthly salary, and then print whatever that is stored in the monthly salary variable. Then we are having our second derived class called hourly employee. It is derived from the same base class employee. It has two variables. The first variable is hourly rate, and the second variable is hour worked. Okay, and this is my constructor. So whenever that I want to create an object of this class, I need to have three arguments because I have a constructor, and this constructor requires three arguments. So whenever we are creating an object of this class, we need to have three arguments as well. And the first argument is a string, and this first argument is again going to call the employee constructor and assign the argument string to the name variable, okay, which is the protected variable of the employee class. Then the second argument, that is rate, is assigned to hourly rate variable, which is a variable of the hourly employee class. And the third argument, which is hours, is assigned to hours worked variable in the hourly employee. Then we are having the calculate salary class, and in this calculate salary, we have this formula. So the total salary equals hourly rate multiplied by hours worked. And then we are showing this message in the output. For example, hourly rate, we print the hourly rate variable, and hours worked, we print the hours worked variable, and then the total salary is being printed out that is calculated just above. So this was what happens in the base class and two derived classes. It may be a bit abstract, but when I explain it with an example, it will be very understandable and easy. So here is my main class, okay? Here I'm creating a vector of employee pointers that is called employees, okay? So I'm creating a vector of employees vector that is called employees, okay? And then we are adding these employees. So dynamically we are allocating, for example, salary employee object and storing its pointer in the vector employees. Okay, this is the name of the vector. And here again, we are dynamically allocating hourly employee object and storing its pointer in the vector employees. Okay, so it's a vector of employees pointer. And here we are basically dynamically allocating the object and storing their pointer in this vector. Okay. And then whenever we are, now that we are dynamically allocating the object, because the salary employee class here has a constructor that requires two arguments, one string and one float. Here we need to have these two arguments, so one string and one float. The first string is Alice. So when this object is created, salaried employee, when the object is created, these two arguments are passed. The first argument is going to call the employee constructor and assign the passed string to the name variable. Okay, so Alice now equals the name. And then we are having this second one that is salary assigned to the monthly salary. Okay, so for Alice, we stored the string and then we stored the salary. So for Alice, for example, salary is 5,000. And when we are creating the object, because we are having a constructor here with two arguments, we need to assign these two arguments as well. And here, when we are having the hourly employee object being created, we need to have hourly employee constructor has three arguments separated by two commas. Okay, so we need to have three arguments. Here, the constructor, the first one is a string, second one is a float, and the third one is an integer. So the first one is a string, and the other twos are two numbers, so they are correct. So Bob is the first argument, which is a string, so it is going to call the constructor of employee with this Bob argument, and this constructor is activated, and Bob is assigned to the name variable. Okay, and then 20, number 20 is the rate because it's the second argument, and rate is assigned to hourly rate variable. And then 160 is the hours, and it is assigned to hours worked variable. So when we are creating the object, we are also activating the constructor automatically because we need to pass these arguments. Then we would like to display information. So for each EMP that is iterating through the employees vector, we are going to call the display info and calculate salary function. Okay, so we are going to have two iterations. Why two iterations? Because we are having two employees only. Okay, if we were having three employees, we were having three iterations here. Okay, so the first iteration is for Alice, And when we are calling the display info, this display info function is activated and the name Alice that was stored in the name variable is going to be printed out. Okay. Then calculate salary. So when calculate salary function is called, this calculate salary function is activated because we are now talking about Alice, and Alice was from the salaried employee class. So salaried employee class has this calculate salary function, and it is going to show this message monthly salary, and the monthly salary of Alice is going to be printed out because when we created the object, we activated automatically this constructor, and salary was assigned to monthly salary variable, and now monthly salary variable is being shown in the output. This is the number that we assigned. So in the first iteration, we are going to see, for example, Alice and then 5,000 as the monthly salary. And in the second iteration, we are going to, when the display information is called, we are going to have Bob, and then calculate salary is called. So the calculate salary is, this calculate salary is called from the hourly employee class. Then we are going to have this message being shown in the output. So the hourly rate, the hours worked, and the total salary. So it is going to show, for example, 20, 160, and then the output of 20 multiplied by 160. It's going to calculate this number and show in the output. And here we are deallocating the memory, so we're cleaning up the memory. So when I run this code, here we see, for example, name Alice. So in the first iteration, name Alice and monthly salary 5,000. Then name Bob, hourly rate $20, hours worked 160, and total salary is 3,200. So this is how actually that we can have an employee payroll system in C++ using classes, base class, a base class, and two derived class to have two payroll system in our, for example, company. Thank you for watching. Hello, welcome to this video. Today we would like to write a program to calculate the area of different shapes: circle, rectangle, and triangle using polymorphism. Each shape should have its own way of calculating the area. We would like to use polymorphism to handle these shape-specific calculation. So let me explain what's going on here. I'm having a base class here called shape, and here we are having a pure virtual function called calculate area. And we know that it's a pure virtual function because it is equal to 0. Then we are having our first derived class called circle that is derived from this shape base class. It has one variable called radius. And here in the public part, we are having the constructor. So when we are creating an object of the circle class, the constructor is going to be activated. Therefore, when we are going to create an object of this circle class, we need to have one argument as well. And this argument that is of float type called R, for example, is assigned to the radius variable that is of float data type. Okay. Then here we are having a function called calculate area. And here in this function, we see that it's a void function, so it's not going to return anything. And basically it is calculating the area using this formula and assigning it to the area variable. And then showing the area in the output, saying that circle area, and then show the stored number in the area variable in the output. Then we are having our second derived class called rectangle. It is derived from the same shape class. It has two variables, length and width. Then the constructor is there, and the constructor requires two arguments. So the first argument is assigned to the length. The second argument, W, is assigned to the width variable that these are the variables of the rectangle class. Here in the rectangle class also we are having its own calculate area that is going to override the pure virtual function of the base class that we are having here. And then basically in this function, we are having the length multiplied by width assigned to the area variable, and we are showing the area in the output. And finally, we are having a class, the third derived class called triangle. It has two variables, base and height. Then the constructor requires also two arguments, and the first argument is assigned to the base variable, the second argument h is assigned to the height variable, and then this triangle class also has its own calculate area, and using this formula the area is calculated and assigned to the area variable, and we are showing it in the output. Now here we are having the main function, and we are creating an array of pointers to shape objects. Okay, here we are creating an array with size 3 of pointers to shape objects. And then in order to create shapes, this array, okay, this is an array with size 3. We need to have 3 elements because the size is 3 and we are having 3 classes, so we would like to have 3 elements in this array with index 0, index 1, and index 2. So here, for example, in this one, shapes index 0 assigns new circle with radius 5. Okay, new circle with radius 5. So it creates a dynamically allocated circle object with radius 5 and stores its pointer in the first element of the shape array. Okay, now here when we are having the this circle and then the 5, when we go up back here again, we see that here we were having a class called circle, and we are calling this constructor because we are creating the object. We are calling this constructor and with one argument 5 there, and this 5 is assigned to the radius variable automatically. Okay, here we are creating a dynamically allocated circle object with radius 5 and store its pointer in shape array as the first element of the shape array. Okay, that and the first element of this shapes array is index 0. We are doing the same thing here also for the rectangle, and here also as the third element of the shapes array for the triangle. So when we are creating this with 4 and 6, rectangle constructor is activated, and 4 is L is assigned to the length, and W is 6 that is assigned to the width. And the same logic goes here, the triangle with 3 and 8, so this constructor is activated. So 3 is the base, so it is 3 is the B, it is assigned to the base variable, and 8 is the H that is assigned to the height. So we are creating and activating the constructors here as well. Then in order to display them, we are going to have a for loop to iterate over the elements of this shapes array. And in each iteration, so I is going to take values 0, 1, and 2. So because I starts from 0 and it is going to continue as long as I is lower than 3. So it is going to take 3 values because we are having 3 objects here and 3 classes that we are going to work with here. Okay, we could have another object here also. We could have like another object for another triangle, for example. This could happen. But here in this example, we only have 3. We're only having these 3. So these are the 3 objects that are created. So here is the for loop. So I is going to take 3 values. in the first iteration, the first element of the shapes array is pointing at this calculate area function. And if you remember, in each class, we were having a specific calculate area. So when we are talking about the first element, which with index 0, I equals 0, and shapes is the array of pointers. Okay, it's a pointer array. So it is going to talk about the first element with index 0, which is the circle, and the circle class has its calculate area function. Therefore, this formula is uh, calculated in as and assigned to the area variable, and then this area variable is shown in the output. Okay, so for the I equals to 0, the calculated area is going to activate it for the circle, because the first element with index 0 is for the circle. And then in the second iteration, when I equals 1, this calculate area function, when it is activated, it is dealing with the rectangle class, because the second element is having index 1. So this is index 1, and we are talking about, we were storing the rectangle as the second element. Therefore, this calculate area in the rectangle class is activated, and using this formula, the area is calculated and shown in the output. And finally, when I equals 2, this array of this pointer array with index 2 is pointing at the calculate area function, and with index 2 we were having the triangle here, and here when we go up, we see that the class triangle was having its own calculate area function. So this calculate area this time is going to be called, and then using this formula, the area is calculated and shown in the output. So when I run this code, we see this. So circle area, in the first iteration, 0 was for the circle. So circle area is 78.5. Rectangle area, this index 1 in the second iteration, is 24, which is true. So 4 multiplied by 6 is 24. And then triangle area is 12 for the index 2, which is the third iteration, and 12 is calculated based on the half, like 0.5 multiplied by base multiplied by height. So it's like multiplying 3 and 8, which is 24, and divide them by 2, which is 12. So we see 12 in the output. So this is how we can have, for example, a program to calculate area for different shapes using polymorphism. Thank you for watching. Hello, welcome back. In this video, we would like to simulate a banking system. We would like to write a program to simulate a banking system where users can withdraw money from their account, use exception handling to prevent overdrafts, for example, withdrawing more money than available in the balance, and display an appropriate error message. Here is my class, insufficient funds exception. It is derived from the runtime error class, that is a standard exception class used for error handling, and we are having a constructor. So whenever this constructor is shown, this constructor, is called, this error message is thrown, okay? Then we are having a function here that we are going to discuss later. And this is my main function basically here. So I'm having a balance variable initialized to be 500. And we are going to have a variable called amount. We are going to read read from the user this amount. So we are going to say, for example, your current balance, and then, for example, show 500. And enter amount to withdraw. So the user is going to, for example, enter 100. So 100 we want, and 500 we already have, so it's okay. But the user might enter, for example, 2000 when their current balance is 500. So it's a risky operation. Therefore, the user may make a mistake. Therefore, it's better to use try, throw, and catch mechanism. This is why I'm calling the withdraw function in the try block. Okay, I call the withdraw function with two arguments, balance and amount. So balance we know here, and amount is taken from the user. Here is my withdraw function, and we can modify the balance because it's a call by reference, the first argument. First of all, we are going to check if the amount is larger than the balance. For example, if we would like to withdraw 2000 and the balance is 500, it means that 2000 is larger than 500, which is a mistake. Then we are going to use the keyword throw, and this message is thrown. Okay, so insufficient funds exception constructor is called, and this message is thrown, insufficient funds for withdraw. When this is thrown, we come back here and we have the catch part being activated. And this catch part actually is going to return the error message passed to the runtime error, which is then printed. So here it is going to say error, and then the error message is going to be printed out here. So if the amount is larger than the balance, we are going to we are going to call the constructor, let's say, and throw this message, and then the catch part is going to catch that message and show it in the output. Okay, but what if the amount is not larger than the balance? So it's not a problem. Therefore, when amount is lower than balance, this condition is not true and this part is not executed. Therefore, the amount is being reducted from the balance. And we are saying withdrawal successful, remaining balance, and we are going to have the new balance because already it was, for example, 500 and we wanted the amount to withdraw, for example, of 100. So 500 minus 100, it is being done here, and now balance is 400. And because we are using a call by reference, we are allowed to modify the balance. We are modifying the balance. Now the balance is modified and we are showing it in the output. So let me run the code. It says your current balance, this part is being printed, your current balance is 500, for example. Enter amount to withdraw. So I would type down 100. When I type down 100, it comes here. It is the withdraw function is called with balance and amount. So balance is 500, amount is 100, for example. And then this function is called. We are checking 100 larger than 500, no, and then okay. So already it was 500 minus 100, it will be 400. It says withdrawal successful, this message is shown. Remaining balance is 400, so 400 is being printed in the output. So if I run the code one more time and I type down I would like to withdraw 400, it says withdrawal successful, remaining balance 100. And when I run the code and I enter, for example, 2000, it says error. You see here, this error message is being shown, and then insufficient funds for withdrawal. This runtime error is printed here. So we are going to call the constructor and throw this message. Okay, insufficient funds for withdrawal, and using the catch block, we are going to print out that message error, then insufficient funds for withdrawal. So basically, this is how we can have a simulation of banking system and how we can withdraw up to certain amount of money, and above that, if we go beyond that, we are going to have some errors. Thank you for watching. Hello everyone, welcome to this video. In today's video, we would like to write a program that accepts a user age and ensure it's valid and non-negative and below 150. So this is the condition for an age to be valid in this program. And we would like to use exception handling to reject invalid inputs and display appropriate error messages. Here is my main function. We are having age that is of integer type. It is being declared here, so the name of my variable is age. Then we are asking the user to enter your age. When the user is going to enter a number, we are going to store it in the age variable. Then we would like to check if the age of the user is valid or not. And these were the conditions for validation: non-negative and below 150. But there is a potential that the user may make a mistake. For example, enter a negative number or enters an invalid number, which is like 300, and it's not reasonable for the age. Therefore, because there is a possibility of making a mistake by the user, we are going to use try block to make sure that everything is okay, and everything, if there is something wrong, we are going to tell the user, okay, you're out of range or you're entering a number that is negative, etc. So we're going to show the message, the error message. So we need to use try, throw, and catch mechanism to do that. Here in the try block, I'm trying to call the validate age function, and I'm passing one argument, which is the age that we got from the user. So this validate age, so the name of the function is validate age, and it's a void type, so it's not going to return anything. And it accepts one argument that is of integer type. So in the beginning of this program, we are going to check if this entered age by the user is below 0 or not. So if the age is below 0, it means that it's not valid because it was one of the conditions in the program statement. So non-negative age, okay? So if it's below 0, throw this error message saying, for example, invalid argument, and the message is age cannot be negative. When we throw this invalid argument, here in my catch block, I catch that invalid argument, okay, and show this message to the user. So in case the user is going to enter a number that is a negative number that is lower than 0, we are going to show this message: age cannot be negative. And in case that age is larger than 150, we are going to throw this out of range message, that is, age exceeds a reasonable limits, must be lower than or equal to 150. And here in my catch block, I'm having this out of range thrown message. So we catch it here and we show this error to the user saying that, okay, age exceeds reasonable limits, must be lower than or equal to 150. And if neither of these two situations are the case, we are going to say, okay, age is valid, and print out the age that the user entered. So when I run this code, it says enter your age. For example, I type down 33 and it says age is valid. So 33 is being printed. So when I enter 33, it is stored in the age variable. Here we are in the try block, we are calling this validate age function and passing this 33 as the argument of the validate age function. Here it says 33. Is it lower than 0? No. So this condition is not true. So we are not going to enter this if condition. We are going to check now this one. It says age is larger than 150. Is it true? No, 33 is not larger than 150. Therefore, this part is also not going to be executed. And finally, it is going to show this message, age is valid. And then we are seeing this message in the output. Age is valid and 33 is printed in the output. So if I run the code one more time and I enter, for example, -20, like imagine that I just made a mistake and I enter, it says error, age cannot be negative. So when I enter -20, it is stored in the age. We are calling this validate age function, and then I'm passing this -20 as the argument. So it checks here, -20 is lower than 0. Is it true? Yes. Therefore, this part is executed, this if condition is executed, and we're going to throw this invalid argument message, age cannot be negative. And here in this catch block, we are catching that invalid argument, and we are showing this message saying that error, age cannot be negative. If I run the code one more time, and this time I'm going to enter, for example, 180, It says error, age exceeds reasonable limit, must be lower than or equal to 150. And in this case, when I type down 180, it is stored in the age variable, and we are calling the validate age function and passing this 180 as the argument, and we are going to check 180 lower than 0, no, so nothing happens. We check here 180 larger than 150, yes, so throw out of range error message, which is age exceeds reasonable limit. This is exactly what we see it here, and we are going to catch this error out of range in the catch block and show this message to the user: error, age exceeds reasonable amount of time, and it must be lower than or equal to 150. So this is how we can have multiple try and catch, try, throw, and catch mechanism in a single program, and we can use this exception handling to reject invalid inputs and display appropriate error message to the user. It's very important because there are certain programs that we are going to write and the user may make a mistake, and it's nice to have a try, throw, and catch mechanism to understand exactly where the problem comes from. Thank you for watching. Hello everyone, welcome to this video. In today's video, we would like to write a program that validates a user's password based on the following rules. So the password must be at least 8 characters long, and it must contain at least one uppercase letter, one lowercase letter, and one digit. And we are going to use exception handling to reject invalid passwords and display the appropriate error messages. Here is my main function. I have a string called password, and I'm asking the user enter your password, and I'm going to store it in the password string. Then, because we want to make sure if the user is going to follow these 3 rules or not, so they may make a mistake, we're going to use the try, throw, and catch mechanism to make sure that the user is not making any mistakes. Therefore, we're calling the function inside the try block. Here is my function name, validate password, and I'm passing the password string as the argument of this validate password function. So here is my function. Okay, this part is my function. This function name is validate password. It's a void type, so it's not going to return anything. And it has one argument that is of a string type, and we are using the call by reference. So we're going to directly work with the original string, but because we want to make sure we are not making any changes, we are using the const keyword in order to make sure we are not going to do any modification to the original entered string by the user. First of all, we are going to check if the password that is entered by the user is having at least 8 characters long. To do that, I use the length function, and I have an if condition here. I check if this string is at least having 8 characters. And in order to count the characters, I use the length function. So if the length of my string is lower than 8, we're going to throw this invalid argument and saying that password must be at least 8 characters long. And here in my catch mechanism, I'm going to catch that error message and show it to the user. Okay, so in case that it is less than 8 characters, we are going to have this error message. And then we are having 3 Boolean variables. So has upper, has lower, and has digits. And all of them are by default assigned to be false. And we are going to see if they're going to be true or not. To do that, we are iterating through this password string. For each character called C, we are iterating through this password string. So here in each iteration, we are checking if this character C is having uppercase, if it has any uppercase, we are using isUpper function. So this is the function that we are using, isUpper. We are checking to see if the C character is uppercase or not. And we are going to use the isUpper function to check if this character is uppercase or not. So if this C character is uppercase, assign true to has upper Boolean variable. If this C is in lowercase, assign true to has lower Boolean variable. And then if this C is a digit using the isDigit function, just assign true to the has digit Boolean variable. Just for example, assume that I'm entering, this is my string. This is my string, okay? So first of all, we're going to check if it has at least 8 characters or not. So this one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 characters. So we are not going to enter this part, okay? Because 10 is not lower than 8. So this if condition is not going to be executed. And here we are going to have an iteration for each character of my string. So first we are going to have R. Is it upper? No. So it is not going to assign true to has upper Boolean variable. Is it lower? Yes. So true is assigned to has lower. Is it digit? No. So this part is not going to execute it as well. Then we're in the next iteration, we are going to move to the next character, which is E. So E, is it upper? No. Is it lower? Yes. So true was already assigned. Is digit? Yes, true. So true is assigned as well. Okay. Is it digit? No. So we are not going to assign true to it. So after going through all the characters one by one of this string, we are going to see this message. For example, if has upper equals false, when we are having it written like this, it means that if has upper Boolean variable is false, through this message, runtime error and password must contain at least one uppercase. So this password is not having any uppercase. Therefore, in the first if condition is this one. So we are going to have this message shown in the output. So when we are throwing this message through the catch block, we are going to catch that error message and show it in the output. If the has lower is false, which is not the case for this example, we are going to say password must contain at least one lowercase. And if has digit Boolean variable equals false, it means that our password is not containing any digit. So throw this error message, password must contain at least one digit. So let me run the code one time. So this is my password, Reza. It says password must be at least 8 characters long. So Reza is stored in the password string, and we are calling this function and passing Reza as the argument. Here in the function, we are checking to see if the length of the password, which is Reza, is lower than 8. This is true because the length is having only 4 characters and it is lower than 8. So password must be at least 8 characters. This message is thrown, and through the catch block, we are catching this message and showing it in the output. So okay, now I know that I need to have at least 8 characters. Now I'm revising my password. I entered this and it says password must contain at least one uppercase letter. So we iterate through all the characters of the password Reza Shahin one by one, and we check that we couldn't find any uppercase there. And because the first condition is checking for uppercase, the message password must contain at least one uppercase letter is thrown, then it is catched here, okay, and it is shown in the output. Therefore, okay, now I understand I made a mistake. I need to have at least one uppercase letter. Okay, I revised my password. So I type down Reza Shahin with uppercase R and I enter. It says password must contain at least one digit. So here in the iteration, We check and we find at least one uppercase letter. So we assign true to the has upper Boolean variable. We check and we see that we at least have one letter that is in lowercase. So assign true to has lower Boolean variable, which was initialized to be false. But we checked that and we found that in neither of the characters we can find a digit. So true is not assigned to has digit. It is still false. Because it is still false, this if condition is activated. So we are saying has digit Boolean variable is false. If this case is true, which is true in this example, throw runtime error password must contain at least one digit and catch this error and show it to the user here. So now I understand that, okay, I also need to contain at least one digit. So I type down Reza Shaheen 111. Okay, let's say I have one digit. It says password is valid. How come we are having this message? Password is valid, and the reason is we are going through the characters of this string password Reza Shaheen 1, and we see we have one uppercase at least, we are having at least one lowercase, and we are having one digit. So this is what we were looking for, and this is exactly uh, what we were looking for to have a valid password. So when we call this function and neither of the exceptions are thrown and we have no errors, then in the next line we are showing this message password is valid, which is here that we see it. Okay, so this is how we can simulate a situation in which we are going to check for the password of an account. For example, you want to create a profile online, and for example, your customer would like to choose a password for their profile, and they must follow these three rules. And this is how we can have the rules being implemented and show this message also to the user. Okay, you're creating a password, but it needs to be at least 8 characters long for security reasons, and it must at least contain one uppercase, one lowercase, and one digit. And if you're making mistake in any of the parts, we are going to show the relevant and appropriate error message to the user. And we could also consider more, for example, more criteria and more rules for choosing the passwords. For example, we could say it cannot be your first and last name. It could be at least like a 10 characters line, etc. It depends on us. We can further practice this practical example in C++. Thank you for watching. Hi, welcome to this video. In today's video, we would like to write a program to create a class called triangle that has private members variables for the length of its 3 sides. And we would like to implement member functions to determine if the triangle is equilateral, isosceles, or scaling. So here is my class. In the private part, I'm having 3 variables called side 1, 2, and 3. In the public part, I'm having a constructor and it has 3 arguments, S1, S2, and S3. First of all, we are going to check if these 3 arguments are larger than 0. If they are larger than 0, this condition is passed and we are assigning S1 to side 1, the first variable, S2 to side 2, the second variable, and S3 to side 3, the third variable. If they are not larger than 0, we are going to show this message saying that invalid triangle, setting default values 1, 1, 1. So, and then we are going to assign define default values for these 3 sides that we are having, side 1, side 2, and 3, and we are assigning it to be 1. This is my constructor, and here is the function. So this function is going to determine the type of the triangle. The function name is determine type, and it's a void type, so it's not going to return anything. We are saying that if side 1 equals side 2 and at the same time side 2 equals side 3, show this message that the triangle is equilateral. And if side 1 equals side 2 or side 2 equals side 3 or side 1 equals side 3, the triangle is isosceles. And otherwise, the triangle is scaling. So these are the rules to find the types of triangle. Okay. And afterwards, we are going to have a display function, and in this display function, we are going to say triangle sides, side 1 and side 2 and side 3. So whenever this function is called, this is going to print the sides of the triangle for us. So here in the int main function, we are creating object t1 from the triangle class, object t2 from the triangle class, and object t3 for the triangle class. And here is we are when we are creating the object of the triangle class, because we are having a constructor, we need to have 3 arguments, and these are the sides of the triangle that are included in the arguments here. So these 3 numbers or arguments, let's say, are exactly the numbers that are going to be assigned to side 1, side 2, and side 3. So the first argument basically is side 1, second argument side 2, and third argument side 3. The same logic goes for the object 2 and object 3. So in T2, we are having 3 arguments. So this is the side 1, side 2, and side 3. Side 1, side 2, and side 3. Afterwards, we would like to display sides. So we're calling for this function. In order to call this function, we are typing down the object name for example, for the first object, t1.displaySides, and then t1.determine type. So this is the determine type. And based on these 3 values for the sides, this function is going to determine the type of this triangle. For example, if side 1 equals side 2, for example, this case 3 equals 3, and side 2 equals side 3, side 2 equals side 3, so this is a triangle of equilateral type. So therefore, this function is going to fall into this condition, which is true. Then execute this part of the code saying that the triangle is equilateral. Okay. Then we are using the second object to call the display side. So we are going to print these 3 sides, which are 4, 4, and 5, because the constructor automatically assigns these 3 arguments to be side 1, side 2, and side 3. And then we call the determine type function. And in the determine type function, first of all, it starts with the first condition. Side 1 equals side 2. Yes, this one is correct. And side 2 equals side 3. 4 is not equal to 5. So this condition is not true. We check this condition. Side 1 equals side 2. This one is true. It says or. We are having the or operator. So either this one or this one or this one. If at least one of them is true, we are going to execute this part. And one of them is true actually. Side 1 equals side 2. So the triangle is isosceles, okay? And that's enough for checking. And or, after the or operator, we were having side 2 equals side 3. They're not equal. Side 1 equals side 3. They're not equal. But side 1 equals side 2. So this condition is true, and that's enough for an and for or operator. So this message is shown in the output. Then using the third object, we are calling the display sides. So 3, 4, and 5 are being shown here. Then we are going to determine its type, and the types, in order to determine them, we are having this function. It says side 1 equals side 2 and side 2 equals side 3. So this condition is not true. It says side 1 equals side 2, or side 2 equals side 3, or side 1 equals side 3. So neither of these 3 conditions are also true. Therefore, it falls into this part where we are having this type of the triangle, scaling. So this is how we can have a class of triangle, have 3 private members, and have a constructor to automatically initialize our members, and then a function that determines the type of the triangle, and finally to display the side. So when I run this code, it says triangle sides 3, 3, 3. So this is the first one, and this message is showing the triangle is equilateral as we expected. And then we are having the triangle size 4, 4, 5, and this is the type of the triangle. And then we are having triangle sides 3, 4, 5, and it says that this is the type of the triangle. Actually, in this video, we learned how to create a class of triangle and determine the types of the triangle based on different input that we are willing to provide while initializing our object of the triangle class. Thank you for watching. Hi, welcome to this video. In today's video, we would like to design a structure called car and store details like car ID, model, and rental rate per day. We would like to write a program to input data for 3 cars and calculate the total rental cost for a specific number of days and display the result. Here is my structure. I use the struct keyword to create my structure called car. There are 3 variables: car ID, model, and rental rate, and these are integer, string, and double respectively. In the main function, we are creating a variable called numCars, and it is initialized to 2. For example, we are offering 2 cars only, and that's it. We are creating an array of objects of the car structure, and the size of it equals to the size of this variable, which is 2. Then we are having a new variable called rental days. We are having a for loop starting from I equals to 0 as long as I is lower than 2. So we are having 2 iterations, I equals to 0 and 1. So I equals to 0, I equals to 1. Okay. So there we are going to ask the user to enter the information for the first car and the second car as well. In the for loop, we are first saying that, okay, car number, for example, 1, because I starts from 0, we are having I plus 1. So 0 plus 1, it's 1. So in the first iteration, we are showing car 1, enter car ID. Whatever the user is going to enter, we're going to store it in the car ID variable, which is in the structure. And to access that, I'm using the object of array, an array of these objects, and the element of this will be the index 0. So the first element is being filled. So we are having cars with index 0 dot car ID. Okay, because we are in the first iteration and I equals 0, so it means that we're talking about the first element car ID, the car ID of the first element of the array of cars object, which is an object of the car structure. Then after storing it, we are showing that's okay, enter the model name, and then we are going to use the get line to store it in the model string here, and again we use the array of objects with the index I, and in the first iteration I equals 0, in the second iteration I equals 1. And finally we are going to say enter rental rate per day, and whatever the user is going to enter, again we are going to store it in the rental rate variable in the structure car using this array of objects. Okay. And then we go back up again, and I equals 1. We are going to ask the same information from the user for the second car, for example. If we want to have 10 cars, we are going to continue this loop for 10 times, and this number should be 10. And finally, in the end, we are going to ask the user enter the number of days for rental. And whatever the user is going to enter, we are going to put it here. And because rental per day, here rental rate per day, and how many days you want to take it, so we calculate the amount. Having a for loop here, we are having the rental days multiplied by rental car. Here for each car, I, because we are having 2 cars, so 2 iterations, and the total cost of the first car and the second car are different. Then Again, using the for loop, we are going to show this information in the output: car ID and car model, for example, and here the rental rate, and finally the total cost. We are going to show it here, and because we would like to have it in a nice table, I'm using the set w. In the parentheses, we are having the number 10, so there is 10 character space. So let me run the code. So when I run the code, it says car 1, so this message is shown, and then enter car ID. I would say car ID is 1, for example. Enter a model name, so I would say Toyota Corolla, okay? And rental rate per day, so I would say $60, let's say. This is just an assumption. Now it says car 2, so the information for the first car is stored now in the structure. So now we are going up again and we are asking about car 2 here, okay? It says enter car ID, so I would say car ID is 2. I would say Nissan Sentra, or then it says rental rate per day. I would say, for example, 65, let's say. And in the end, it asks me, after having the two iteration, it asks me enter the number of days for rental. So if I would like to rent, for example, for 4 days, it gives me a detailed table here, as you see. So it says car ID, the model, rate per day, and total cost. So car ID is 1 and 2, then the model Nissan Corolla, Toyota Corolla and Nissan Sentra, and then the rate per day $60, $65, and total cost is shown here. On total cost, if you remember, we calculated here rental rate multiplied by rental days, okay? And we are having this summary table in the output as the output of our work. For example, we could have another column for taxes and for I don't know, for petrol cost or any other things, and then calculate the total cost. It depends on you. But in this video, we learned how to create a system like for rental car companies to have a structure to store the data related to different cars. For example, having the ID of the car, having the model and the rental rate, and based on the user input on, for example, how many days they would like to consider this rental, then we were able to calculate everything for them and show a clear and nice table in the output with the total cost included with the rental day calculated, based on the rental rate and rental days. Thank you for watching.